All right, it's space weather. We're looking at a filamentary coronal mass ejection eruption on the southeastern limb of the solar disk. Check it out. It's in the processing of ejection right now. Noticed it earlier, was wondering if it would erupt, and indeed it did. Take a look at 171 angstroms. You can see it in this view also. Great indication of the magnetic looping involved. And look at the magnetic lines. See if they're still as dense as they were. And indeed they are. See the way the lines are all gathered on the sun here? There's a big empty space. Coronal mass ejection. Now, before we get on with the report, going to respond to some commenters. First of all, thanks Aluminum Rain, you must be our top commenter. Thanks Chuck Tiber End, Manuela Starseed, and Oh Nice. All those people commented on the video yesterday. Manuela Starseed says, can you tell more about the electrons and how they interact with cosmic rays, and can you tell more about the electrons and how they interact with cosmic rays when they are high and when they are low, like now? Is it some kind of shield, and what is high-low bombardment from electrons? There is very little information to be found about the electrons. Thanks. Okay. So, what we're talking about here is the GOES electron flux. We're going to leave links below for this. Here's the GOES electron flux. Now, this GOES satellite is measuring the stream of electrons at the Van Allen belt. I'm going to explain what that is in a moment. Let's just skim over their explanation. You're looking at electron flux with energies between 0.8 mega electron volts and 2 mega electron volts. Now, this is not directly from the sun. This is measuring it in the Van Allen belts. So the sun is always spitting out some electrons, and we're always interested in how many of them, how dense that electron flux in the Van Allen belts is, because that has a great effect on satellites. If there's a lot of electrons, if there's a surplus of electrons, the satellites will begin to charge up with excess electrons internally and externally eventually. That's not good for satellites. The reason that I follow this is because I view this as a tidal force, because when you see changes in this, that indicates that there are changes happening in the magnetic field configuration and particle acceleration loss. Keep in mind, this stuff always wants to be at equilibrium. So if there's a shortage of electrons, the Earth wants to give up electrons. If there's a lot of electrons, then there's electrons to spare, and it affects the way the radiation hits the planet. Now, as far as a shield to cosmic ray flux, the electrons don't really do too much of that, other than the fact that they're creating current in the Van Allen belt. So they do it in an indirect fashion by creating electromagnetic fields, and they help the strength of the charge-aligned currents as the solar wind heads to the north and south poles. I hope that cleared it up a little bit. Now, interestingly, I found an article on Space Weather about new satellites that are looking at the very high energy electrons. Because keep in mind, the GOES satellites are only picking up electrons in certain voltages. Let's just go back to that for a minute. See, the GOES 14 and the GOES 15, they're, you know, that's a check and balance. So you can see if there's a disparity on one side of the planet versus the other side of the planet. And that's why we've got two satellites measuring the same thing. In any case, some students have launched from Vandenberg, California, 2 new satellites. Wait, 2 satellites? I think 2 satellites. Yep. And what they're doing is they're measuring the ultra-high energy electrons, known as killer electrons. They've just received the first report. We're not going to listen to it because I have no idea what this format is. But here's another diagram of how this works. Now, keep in mind, electrons are not very massive, so they're subject to all kinds of different forces, and they're extremely powerfully negatively charged. So whenever they reach anything positively charged, they stick to it. And they're pulled around and formed into streams very easily, especially through electromagnetic fields, which are the main influence between the sun and the earth. In any case, again, links to the description. We will link the article below. Not going to read it during the report because we got to keep it short. Now, while we're on the subject of electrons, if you go to the Space Weather Enthusiast page, you can look at the real-time electron count in the U.S. Great little graphic there. Again, links in the description. There's your current situation. As you can see, it lines up there very low. Very low, very low. Take a look at the real-time solar wind. Also very low. That coronal hole wind stream has subsided, it appears. I mean, 332 kilometers per second for a wind speed. 4.24 as a, 4.24 protons per cubic centimeter as a density is very low. Now, we do see a phi angle shift again. The phi angle's down to about 140 now or so. So, yeah, not sure on that one. Let's go back and look. Take a look at our magnetic lines and see if we can figure out what's going on. All right, so there's a coronal hole south of the equator, right here. It's very small, it's not very well formed, but according to the magnetic lines, I believe that's what's connected to the Earth. So that's what the phi angle shift is from. Let's look at the rest of the details of the data at spaceweathernews.com. X-ray flux is still flatlined. Phi angle shift is just coming in from that northern coronal hole. Magnetometer lines are crossing, so there's a slight disparity between the GOES 14 and the GOES 15. And the KP index is fluctuating, so that's interesting. Got to keep an eye on that. It was just at 0, now it's up to 2. So a sudden jump. Electron flux looks like it's coming back up. And no charging hazard. Very low electron levels. The F2 ionosphere layer is looking a little discharged and a little bit anomalous, especially in the northern hemisphere portion. And there's your auroral forecast. And there you have it. Thanks again for watching, everybody. Please don't forget to like and subscribe the videos. We will be showing you coronal mass ejections whenever they occur. Please share the videos with your friends on social media. Share the videos with your foes on social media. There goes that CME. Does not appear to be Earth-facing, so nothing to worry about, folks. Not a lot to be alarmed at all, except that grand solar minimums feature you know, catastrophic weather, volcanoes, earthquake, etc. Anyway, when you're being prepared for disasters, don't drink. And if you drink, be prepared for disasters by having some booze on hand.